Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. So today I'll be discussing how to analyze or how to determine the moment of inertia for a quadricircle using the method of integration. So here basically I have considered a quadricircle which is of radius equal to capital R, and also I have chosen the elementary section which is having the width of equal to dr, that is nothing but the radial width, and then it is at the distance of a small r from the center of the quadricircle, and capital R represents the radius of the circle, that is quadricircle, and G represents the centroid of the quadricircle, and d theta represents the angle which is subtended by the elementary section, and then the angle made by the elementary section with reference to x-axis is considered to be as theta. So now I have considered the elementary section wherein this dot represents the centroid of the elementary section. So this centroid is considered to be at the distance of y in the vertical direction from x-axis, and then horizontal distance of x, so that the angle subtended is equal to theta with reference to x-axis. So therefore, by using the knowledge of trigonometry, y can be taken to be as r sin theta and x is equal to r cos theta. So y is the vertical distance or the perpendicular distance with reference to the x-axis, from the elementary centroid for the elementary centroidal axis, and x represents the horizontal distance of the centroid of the elementary section from the vertical axis. So therefore we know that the theta is the angle subtended by the elementary section which is from the x-axis. So therefore y will be equal to r times of sin theta and x will be equal to r times of cos theta. So with this, if I want to find out the moment of inertia for the elementary section, we need to consider dA as the area of the elementary section, and then we know that dA is the area of the elementary section, but when we consider the quadricircle as a whole, compared to that this section is very small. So therefore the curvature of the elementary section could be neglected, and therefore it can be considered as the area of the rectangle itself, wherein its area will be equal to length into depth. So length is equal to r d theta and depth is equal to dr. So therefore area of the elementary section could be considered to be as r times of d theta into dr. So coming on to the determination of moment of inertia for the elementary section. So since we know that the centroid of the elementary section, which is having the perpendicular distance of y from the horizontal axis, so if I just take the horizontal as a reference axis, so the moment of inertia will be area multiplied by the square of the perpendicular distance. So area is dA, perpendicular distance from the horizontal reference axis to the centroid of the elementary section is y. So therefore it is dA into y square is the moment of inertia for the elementary section. So as we know that y is nothing but r sin theta, so substituting the value of dA and y in the equation, we will get the moment of inertia for the elementary section as dr into r d theta times of r sin theta the whole square. So this is the equation for the moment of inertia for the elementary section. So if I just consider the moment of inertia for the overall section, so before considering the calculating the moment of inertia for the overall section, so first of all I need to find out what is the moment of inertia about the base axis. So here the base axis I have considered to be as AB. AB is considered to be as a base axis. So with this base axis, firstly I will determine what is the moment of inertia with reference to the AB axis. So therefore, by using the moment of inertia equation which I have determined for the elementary section and integrating that between the limits 0 to pi by 2, I'll get the values as I'll get the value with for the d theta. So since we have two variables, that is r and theta, so therefore we are supposed to integrate this two times. I repeated. So we have two variables wherein one is theta, that is d theta, and one is dr. So wherein we are supposed to integrate this. Firstly, the d theta term has to be integrated with reference to the limits between 0 to pi by 2, and then the terms of dr, that is r cube dr, has to be integrated separately with reference to the limits 0 to capital R, that is radius. So after integrating all the things, so we'll get the value of moment of inertia with reference to AB as the axis as pi r power 4 by 16. I repeat this procedure once again. So moment of inertia for the overall quarter circle has to be found out by primarily by taking the moment of inertia with reference to some axis. So here I have considered the base axis AB as a reference axis. So firstly, with reference to AB as a reference axis, firstly I need to find out what is the moment of inertia. So with the backup equation which I have found out for the elementary section, the same equation I am going to substitute and integrate the same equation twice. So I need to integrate this equation two times. Why? Because there are two variables, one is d theta and another one is dr. So the sine square d theta value has to be integrated with reference to the limits 0 to pi by 2, and then the r cube dr value has to be integrated between the limits 0 to r. So the same equation has to be integrated two times, one with reference to 0 to pi by 2, the variable is theta, and another one with reference to 0 to r, the variable is dr. So therefore, after doing all this procedure, I'll get the equation of moment of inertia with reference to AB axis as pi r power 4 by 16, pi r power 4 by 16. But I need to find out what is the moment of inertia with reference to centroidal axis. So for this, I just consider the centroidal axis parallel to the AB axis. So I just name it as xx. So I just name it as xx. Okay. So here, by using the parallel axis theorem, I just take IAB as IAB is equal to IXX plus A y bar square, wherein IAB is a moment of inertia with reference to AB as a reference axis. IXX is a centroidal axis of the quarter circle as a whole, and then IXX is a moment of inertia with reference to XX axis, and A is the area of the quarter circle, and y bar is the centroidal distance in the vertical direction with reference to the base as the reference axis. So therefore, IAB in the previous slide, by referring to the previous slide, I got IAB value as pi r power 4 by 16. So IXX I need to determine that, and area of the quarter circle will be considered to be as pi r square by 4. As I know that area of the circle is pi r square, semicircle is half of the circle, that is pi r square by 2, and the quarter circle is again half of the semicircle, that is pi r square by 2, half of that is pi r square by 4. So we also know that y bar will be equal to 4r by 3 pi. So in my previous lecture series, this concept I have explained it. So that is nothing but y bar will be equal to pi 4r by 3 pi. So substituting all the things, I'll get the value as ixx is equal to 0.055 times of r power 4, wherein r represents the radius of the quarter circle. So it is 0.055 times of r power 4. So if you just find out, if you just want to determine the IYY, so it will be same as that of IXX itself as in case of quarter circle. Thank you for watching. Please like, share and subscribe the video. Thank you.